Elkhart Community Schools. My name is Amber Hudson. I'm the Vice President of Educational Services at First Makerspace. We have done a lot of work in coordination with Elkhart Community Schools, and we hope that relationship continues for a very long time. We are creating a training video for 3D printing. And so specifically, we're going to focus in on the Adventure 5M Pro, which if you have not received those 3D printers yet, you will. It's a fantastic piece of equipment, and 3D printing, as you may or may not know, is a valuable manufacturing and production focus among many others, but there is great value in 3D design, CAD modeling, and then 3D printing in the potential for future careers of students that you work with on a daily basis. So in this video, we want to spend a little bit of time talking about the piece of equipment itself, get into 3D design and modeling, and then how we slice and print a 3D. So let's focus in on the Adventure 5M Pro. This is the piece of equipment. It's a decent sized 3D printer. It has a very successful print rate. We recently purchased a 5M Pro and have been so impressed with its capabilities. So excited to share a little bit more about it with you. So just a few things about the machine. This particular 3D printer is the fastest 3D printer created by the Flashforge company. We have been incredibly impressed with its speed, and to the point where it surprises us sometimes. It moves and is rather loud in the way 3D printing generally is, and that's mainly because the speed has increased significantly. So the power button for the Flashforge is on the front side of the machine. That's not typical for 3D printers, but it makes it very nice here. You have a display where every piece of information you need to utilize comes from that display. You have a build plate on the inside. This build plate is removable, held in place by a magnet. It is also a flexible bed, which makes removing prints very easy. There is a filament roll, a holder and a spool on the back of the 3D printer. And those are the basic components of your 3D printer. On the inside of the machine, there is a camera that is available to record recordings. Your extruder is back here in the back. So for 3D printing, the filament feeds from the roll into the machine through a series of motors that allow it to then feed here. It's heated within this element, this component, and then the plastic melts and feeds out of the extruder. 3D printing is known as additive manufacturing. One layer of filament is laid down at a time on top of each other until each of those layers build into the final object that you have designed. Let's talk next about 3D printer filament. The filament, as we showed before, is stored here on the filament spool in the back. The spool itself is a PLA filament. That's probably the most common type of filament used with 3D printing. It's our recommendation for schools because PLA is made of sugarcane and soybeans. So in the process of heating, if you get any fumes at all, they're minor and safe. So as the machine feeds the filament in, we're going to walk through the process of how to load and unload filament, kind of go through the display screen here on the 5M. So for the screen, to begin, once it's powered on, generally looks like this. All of these icons allow you to adjust settings relatively quickly, follow directions very quickly to proceed in your process of printing. On the home screen, you can adjust the extruder temperature and the bed temperature. That generally isn't necessary unless you are finding that your prints are not sticking to the bed, and some adjustments might need to be made. But for the most part, when you slice the software or slice the print, it's going to take care of those settings automatically. The next icon is for builds. So there will be some items that are stored already on your 3D printer. Those are free ones that Adventure allows you to use as test prints. As you print things, some of those items will also be stored kind of in a library here on the screen. Your other option for printing is to print with a USB. So that USB capability is here. And allows you to transfer the file from your computer directly to the 3D printer. Most files are transferred wirelessly if that's an option, that your 3D printer and the computer connected to your 3D printer or with the software on it can be connected to the same network. That's valuable. The next icon is a filament icon. It's going to walk you through the process of how to load and unload filament. You have a settings icon next, the small gear, and this will allow you to change your X, Y, and Z axis, connect to Wi-Fi, or connect the machine using Ethernet. You have access to Flash Cloud here and Polar Cloud 3D. For leveling the bed, this is one of the best new updates we've seen to 3D printing. You used to have to level the bed manually, and it took a very long time. Leveling is now done very quickly with the press of a button. With leveling as well, you do not have to do that very often. The first time you unbox the machine, you'll want to level it. If the machine ever moves from one room to another, that probably would be a good time to level it again, but it's not necessary to do very often. You do have camera access with the Adventure 5, so you can record the prints that are being printed. It gives you some options for choosing those here. And then information about the filtration system that is stored within the machine. We're going to go back to Filament for a second because the first thing that I want to talk about is how to load and unload the filament. When you begin the process of loading or unloading filament, on the display screen, you'll hit load, and it will begin to preheat the machine. This sometimes takes a few minutes to prepare the filament for loading or unloading, but once that is done, I'm simply going to follow the directions that are given to me via the prompts on my screen. Generally, if I'm creating or loading new filament, I would feed it into here, follow it through, and then literally wait for the prompt to tell me that the motor has heated it up enough that the filament can then be pushed into the extruder to load. There's a red button down here. That button too needs to be pressed to feed it in. And because I currently have filament in there, it's telling me that it is loading. And then usually you'll wait for the filament to be extruded. If you're changing colors, there may be some of the color left behind. This will allow you to watch until the new color has loaded. And then the prompt will automatically tell me that it is done. And I can remove and throw away any of the leftover filament. The next step will be connecting to Wi-Fi. As we mentioned before, there are multiple ways that this can be done. We generally find that schools use their local network and connect to the Wi-Fi. We also have some schools that connect theirs via their Ethernet. It's all personal preference and whatever your IT department prefers. But here I'm going to connect to the Wi-Fi, so I choose that option. And then it's going to prompt me to enter the Wi-Fi password. I do recommend having a stylus handy because this process can take a while and it's very easy to mess up. I have successfully entered my password, and you'll see now that the Wi-Fi icon appears up here at the top. So I am connected. It's now ready to begin the process of 3D design. When it comes to 3D design, we prefer Tinkercad as the software design platform. Tinkercad is free, it's web-based, it's easy for teachers to understand and utilize, very quick for students to pick up. To explain that better, you're going to have also included a Tinkercad 101 video that will go into detail about all of the things that Tinkercad has to offer. I find it incredibly valuable for students to understand 3D modeling and 3D design, whether they end up printing something or not. So there are great benefits to that and knowing and understanding how 3D printing works or 3D design works. If you teach upper grade levels and you have a more advanced software for CAD modeling, use that. But Tinkercad is a great place to start if you're just learning how to teach yourself about 3D printing. Regardless, if you want to print something, you have to have it designed somewhere. So you're either designing it yourself or you're choosing a file that someone else has already designed. Most people will use Thingiverse, Thingiverse, Thingiverse.com, to utilize files that have been created and designed by somebody else, and then they have been made available in a library for free. So Thingiverse looks like this. It allows you to access all types of files. So I would be very careful about allowing students free access to roam through Tinkercad. If you wanted to give them an opportunity to choose a file, maybe you have pre-chosen 5 and you're going to share those 5 files with it. But it's definitely worth looking at Tinkercad, especially if you're new to 3D printing and you want to print some very cool things. There are some designers out there that are incredible at what they do, and they provide these in a library for free. The next piece of information that you need, so once you've watched the 3D design video and you have walked through Tinkercad, we have several lesson plans on our First Makerspace website. That is www.1st for first makerspace.com. We have a K-12 curriculum with lots of 3D printing lessons. So once you have a basic idea of how your 3D printer works, you can utilize those lessons to then teach yourself how to design some of these things. So some of the early 3D printing lessons that we typically see are either a name tag, where students are combining some pieces together within Tinkercad to create something with their name on it, and then they print that, or 3D printed bubble wands. Those seem to be really popular. I know a lot of educators like bubble wands because there are some design elements you're trying to put together to make sure that the 3D printer prints a bubble wand that actually works. And there's some science behind that, and teachers like the part of testing to see if they work as well. Once I have designed my file in Tinkercad, 3D files need to be saved as STL files. STL files are what are recognized for 3D printing. So I have opened an STL file. When I finish that design in Tinkercad and save it as an STL, it will automatically save in my downloads. So I can locate it there, and when I open it, it's going to open in Flashprint. So Flashprint is the software created by FlashForge that allows you to be able to slice the software or slice the print. To be able to access that 3D printing Flashprint software, you'll need to go to their website. If you just Google 3D printing Flashprint software, it's going to take you to a site that allows you to choose and download it based on the machine that you have. So again, this is probably going to be more on the IT side, but you won't actually be able to use your 3D printer until you have access to Flashprint. The other recommendation I would give is that the teachers that are regularly going to 3D print need access to Flashprint on their device. So whether that's your personal device or a school device, you would want to meet with IT to make sure that they are allowing you to have access to that Flashprint software. Other schools will also opt to have a dedicated 3D printer in the room where the 3D printers are located, a dedicated computer for those 3D printers. That computer could have the Flashprint software on it, and then that would allow them to access the software that they need to be able to send a file. So once you have Flashprint downloaded and you open an STL file, this is generally what it will look like. For whatever reason, you always get this warning message. You do not have to do a new version of Flashprint unless you choose to. I've already done it, so I don't need to do it again. But this is what Flashprint software looks like. So you can see that the print that I designed in Tinkercad saved as an STL file and opens automatically in Flashprint because this is what's connected to my 3D printer. This is the software that I need to be able to slice the print. It's the third step. So if you kind of think about the equipment and getting the machine up and running, and then moving on to the actual design process, and then there is the printing process. So we're in that third step now. When you get into Flashprint, the very first thing you want to do is choose your machine. When you log in the very first time, it's going to ask you what machine you have. But for example, here at the lab, we have multiple 3D printers. I can click on this little extruder icon, choose machine type, and then pick from a series of 3D printers. These are all going to be FlashForge printers. So I've already chosen the 5M Pro. The nozzle type is going to be important. In the 5, it currently is a 0.6 millimeter nozzle. If you change 3D printers or if you change the nozzle to a different size, you would need to make that adjustment here, but it should automatically set itself for the 5M Pro. That's step 1. Once I'm done with that, you'll notice that there are all kinds of icons down the side here. Those are going to be really interesting to just play around with. I'm currently going to be in view mode. That's automatically what we see. If I want to move the object on the platform, I can do that by clicking on these arrows and then move it to a different location by thinking about the X, Y, or Z axis. I can easily get it back onto the platform or centered by clicking these 2 buttons. I can rotate the object in a variety of ways. This becomes important when it might be an object that wants to print vertically and you need it to be horizontal because that will take up more bed space and probably result in a better print. You would make those changes here. Next, you can change the scale of it. I typically work within uniform scaling so that if I make an adjustment to the print, as you can see it's getting bigger, it's going to scale that with my X, Y, and Z axis. Currently also it's set to millimeters. You can change that to inches, but I actually recommend students getting used to millimeters, so try that. Don't have any models that can be cut right now. I can duplicate those models if I wanted to print multiples on a bed. If I need to space out space between models to get as many on there as I can, but with equal distance between them, I can adjust that here. Supports are going to be an important part of the prints that you do. If you are printing something like what's currently on my screen that is flat already, this is my name tag, it has a base to it. That base I know takes up a decent amount of surface area. It's going to sit on there and probably print with no problems. If I was printing, say, an animal of some kind, this is where supports become very helpful and handy. If I picture a horse and think about what that looks like, and I was going to 3D print it, there are 4 feet that would be touching the platform. That's not a lot of surface area connected with the platform, and as it builds up those 4 legs, it's eventually going to get to where the belly is, and as it moves in that empty space between the legs, the filament is just going to fall down. There's nothing there to support it. So you can add various types of supports to prints that you think might have an issue, that have an overhang of some kind. You can add those in, and I would choose automatic supports because that takes care of it on its own. For something like this, supports are not needed. You've got a few more features that don't necessarily are not used regularly, but you can definitely play around with those. Once you feel good about the way your machine is set up and the print looks on the bed for this flash print, you're going to choose Start Slicing. You're going to get these reminders. You want to make sure that the nozzle type is correct. You want to make sure that you have the correct type of filament. So currently we're using PLA. Make sure the size is correct. And again, once you've done this a few times, this becomes really quick. The extruder temperature and platform temperature are automatically going to be set to that specific printer. I would not mess with those unless you start to see issues with the prints. You have all different types of pieces of information that you can adjust and change over here. If you are new to 3D printing, I would focus on supports. Do you need them or not? And then the raft. So a raft is going to be added to something to give it a bit more surface area to connect to the bed. Sometimes prints will enable the raft automatically, and sometimes they don't. I've noticed that with the 5M Pro, it typically will turn the raft off. That's a quick yes or no here if I want it to be on. I do not need it with this particular print. If you accidentally have a raft printed, it will be a very thin layer of plastic below your print that is peeled away and thrown away when your print is done. So again, I'm really focused on, do I have the correct nozzle size? Do I have the correct type of filament? And then I am ready to slice. Once that's done, it's a very quick process. I do like to go to the slice preview up here because what that allows me to see are all of the separate layers that it's going to take to 3D print this. I can also check up here. I think it's kind of interesting to see the time. This particular print would take me 14 minutes to print 53 layers. So it's kind of cool for students to understand that when you're talking about millimeters, it's laying a very fine layer of filament over and over again, 53 times to get this 14-minute print. On a typical 3D printer, even those that are other FlashForge prints, this would probably take somewhere between 30-35 minutes. So we've noticed that with the Adventurer 5, it cuts the time in about half for all 3D printers, which is phenomenal. I can close out the preview, and then I have two options for sending this to my machine. I can either download it onto a USB and plug that USB into the front of my printer. That's a very easy, reliable way to exchange files. The other way that definitely is great is that I can send it directly to the machine. So if I choose this little extruder image, it will do a scan of all local 3D printers. And what you'll notice right away is that this current printer that's showing up is not my FlashForge 5M Pro that's sitting right next to me. It's a different 3D printer. Sometimes I have found that this is not incredibly reliable. So even though I have this set up, it may or may not work. I may end up going back to sending it the file with a USB anyway. So those are done and the options that you have. I will use a USB to transfer this file and pick up with that. When I am ready to transfer the file to my 3D printer, in this case I'm going to use the download option. And just to be aware, what you'll notice now is that that STL file that I had saved from the design that I created is now, after it's sliced, a GX file. That is the file that a 3D printer needs to read. I'm going to save that to my USB. Oops. Try that again. I will save that here, and now I'm ready to move it to the 3D printer. At my 3D printer, I'll insert the USB. From the main screen, I'm going to go back to the build icon, choose my USB option, and then my name tag appears here. Once I have chosen that option, I want to make sure that the door is closed. And I will choose the green build option. It's going to copy the file. Once the file is copied, I can immediately remove my USB, and you'll see that the 3D printer begins to respond. It's going to show me on the screen that it's ready. It will need to heat up that extruder and bed, so that will take a few minutes for it to do that. Let's see, it will tell me that it is preheating. The time will eventually pop up of 14 minutes. We'll wait for this to heat up, and then it will begin my print. I can observe the process of the preheating. I'm watching it appear here on my screen. To get the extruder to 225 degrees and the bed plate to 55 degrees. And again, I can adjust those as needed. You'll see that the time appeared, 14 minutes, and the process of printing will begin. The 3D printer will always lay down almost like a practice run of filament first. So you'll see it do that down the edge. That's just extra. It's a good test to make sure that the bed plate that the extruder is extruding filament in the way it should be, and then it will begin the process of the actual print. So in 14 minutes, I will have a name tag printed with my name on it. That's how easy it is. My print is now complete. I have no remaining time left. There's my message to click OK. Now when I want to remove the print from the bed, I can manually push the bed down. Just do it rather slowly until I feel like I have enough space to access the build plate. It's going to be stuck pretty firmly, so I'm just going to adjust and bend this until I can get a corner to come up, and you saw how easy it popped off there. As you can see, I have my 3D printed name tag. It's actually a really fabulous print. I'm going to get a good view of it. I've successfully taken something that I designed, and now I physically can hold it in my hands. So the last thing that I want to talk about are some troubleshooting ideas or issues that might come up and ideas for how to fix those things. So the most common ideas or issues that we see with 3D printing can be fixed quite often just by the user. There's a few tips and tricks that I can share that we can try. So the first one typically is an equipment usage issue. Usually some type of clogged filament tube that if you notice during a filament change that the filament cannot pass through the filament guide tube, unload and load the filament again. Sometimes there will be a piece of filament still stuck in the extruder portion, and when you load the filament, it's just enough to push it back through and then extrude it out the other side. If you have a filament extrusion issue, the filament does not appear to be coming out of the extruder when it should be printing, especially when it prints that very first line down the side. That's a good test. Typically what has happened is that the filament that's on the roll has gotten tangled, and so the easiest fix for that is to unload the filament, untangle it on the roll, reload it again, and then just possibly, usually that fixes it. If not, you can check to make sure that the nozzle temperature is correct and matches the temperature that's on the actual filament roll, but usually a tangle issue is the issue. The next most common issue that we see is that the model does not stick to the build plate. I was just working with a school with a 5M that was having this issue. So what you'll find is that when you get your 3D printer, it will come with an adhesion, like a roll-on adhesion. So one of the things a trick we've been doing for a long time is to just take a glue stick and put a fine layer of glue across that build plate. It's not actually the glue itself that makes the build stick, but the chemicals that are within that glue. So the adhesion roll-on that comes with the 5M Pro works the exact same way. Usually that's enough to keep it sticky. You only have to do that maybe every 10 prints or a dozen prints, and you can kind of tell when it starts to not become sticky anymore. You just add a new layer on. Eventually what will happen is you'll get to the place where you've got a buildup of some gunky glue left behind. At that point, if it starts to interfere with the way your print prints, you can kind of tell on this one, like it is so perfectly flat. If you start to see issues with that, then I would recommend taking the build plate out and washing it with soap and water, like a Dawn dish soap, a gentle soap, no scrubbing of it, just literally with your hand, kind of wash it off until the glue is removed, and then add a new layer of glue back on. Usually that is enough to get the print to stick to the bed. Those are the most common issues that we see, and a quick way to fix them. We have a full-time technician that works for First Makerspace, so if you do run into issues that you can't seem to fix yourself, he is happy to hop on a Zoom with you or make the trip to make those fixes to your 3D printer. So thank you for spending this time with me. As always, I want to remind you about the First Makerspace curriculum that is free on the website, www.firstmakerspace.com. Click the curriculum button, create your sign-in, login, and then you have access to that pre-K through 12th grade curriculum. In addition to that, we do have a Teachers Pay Teachers store that has a lot of materials in addition to the free lesson plan. So things like PowerPoint slides, worksheets, rubrics, you're going to find those things there. There are also a series of safety posters included in TPT that does include 3D printing if you feel like that's something you need. As always, you can reach out to me at any time. My phone number is 765-639-2508, or you can email me at amber@firstmakerspace.com. Good luck with your 3D printing. Hello, my name is Amber Hudson. I am the Vice President of Educational Services at First Makerspace. We are a company based out of Indianapolis, Indiana that designs, builds, and sustains makerspaces across the country. This involves a number of components. One major piece is the furniture that we make. We have also a collection of STEM kits and equipment that we include in makerspaces. And then probably our most important piece, and the piece that I oversee, is the professional development that comes along with each purchase that we sell. And so through the process of doing that PD now for several years, I've taken the experience that I had within the classroom. I was a classroom teacher for 22 years in a STEM science classroom. That's my background. And so between the teaching opportunities that I had and now the professional development that I've been doing for the last 4 years, I've really come to find some pieces of equipment, STEM kits, and websites that I really find helpful in a STEM classroom, and Tinkercad is one of those. And so I wanted to share today how Tinkercad works, give you a quick tutorial on what this site offers. There is so much to it, and it is so valuable in a classroom, whether you're a STEM teacher or not. There are multiple ways that you can use this site. So the focus of my presentation today is tinkering with Tinkercad. So the first thing that you're going to need to do on a device is to go to a website that is tinkercad.com. So you can see that listed up at the top, Tinkercad, tinkercad.com. It'll bring you to this page, which is where you would either sign up if you are brand new to Tinkercad or log in here. So the sign up button is in the upper right hand corner. When I click on that, then I want to make sure that I choose the educator's site here. So if you are someone working within a school, whether you want to create a class or not, you would start by creating an account for your classroom. If you were an after-school care program or someone that, say, works in Boys and Girls Clubs or Girls Inc., something like that, you would also create an educator account so that you can have students access your classroom. So from here, after clicking on educators, you'll go through the process of signing up for an account, which is filling in all of your information. Once you have logged in and created an account, it'll take you to the home screen of Tinkercad, which looks like this. And this is kind of where we're going to spend the majority of our time today as we just kind of learn about the different aspects that Tinkercad has to offer. So if I was logged in as a teacher, this would say, instead of create a class. I already have my classes created, but it's a very easy step to add students into your classroom. The benefits of having a class created is that it then stores all of your student designs within your page, which is really helpful if you were to continue on with Tinkercad and go into 3D printing. You would want to have access to your student designs. That's the benefit here. If you were a student logging in, back on that initial first page that we looked at, there's an actual button for students to choose to log in. You would be provided with a class code. You would share that with your students, and then they would automatically have access to your class. So within Tinkercad, we're going to kind of just explore all of the options that you have for using Tinkercad in a variety of ways. So the first thing that I want to point out are these choices across the top. So I'm going to start kind of backwards because I actually like the resources section, and I usually direct teachers here when we're doing professional development with Tinkercad. Under resources, you've got several different helpful tools if you are just using Tinkercad for the first time. So for example, I tend to tell teachers to go to the Learning Center first and have their students start here with these tutorials. There are probably close to 30 different tutorials here, but I would recommend at least having students do the first 10, and the step-by-step directions are going to teach them exactly what they need to know about the basics of Tinkercad. How do you drag and drop an item? How do you adjust the size of it? How do you rotate it? Using the perspective tool to change the design a bit. It's going to walk them through all of that here. Also under resources, from a teacher's perspective, you'll find their collection of lesson plans. They have done a fantastic job of adding to the lesson plans that can be found here in Tinkercad. I love this inclusive play space one because it uses a lot of traditional shapes, basic shapes, as students work to build out a playground that is inclusive for all students. So that's another fantastic resource to work through. And then you'll find a few challenges. The blog here is updated regularly, so those are great resources as well. As you move across the top backwards, you'll find information about creating a classroom, how to join that classroom, some basic information regarding that. Under projects and gallery, you'll find various ideas of projects that teachers and students have done. I found this really helpful when I need an idea or I'm looking for a STEM activity that I want to do that I could use Tinkercad for that maybe I hadn't thought of. So between the projects and the gallery, you'll find lots and lots of different ideas there as well. And then of course, the place where you'll spend most of your time is under the Tinker button. So in here, Tinkercad has 3 specific parts, areas, that you have access to having a Tinkercad account. By the way, the Tinkercad account is entirely free. Every aspect of it is free, which is fabulous, fantastic. I love it when people do that for teachers, so enjoy that as an educator. There are 3 parts. I'm again going to work backwards, kind of going from the probably least used item of Tinkercad to the one you'll spend most of your time in. Code blocks is a feature of Tinkercad that allows students to incorporate block coding into 3-dimensional builds. And so by connecting blocks together, if you're familiar with coding, a lot of coding applications use block coding as their platform, and so that should be rather familiar to students. This particular block coding in here can get very detailed and in depth. I had to watch a few YouTube videos myself to be able to understand this a little bit better. But by connecting the blocks, you're then building out structures, because a lot of the structures that you build using coding are repeated over and over again, very similar to how this DNA structure is building upon itself. That's where the coding platform works really well. So here's one using a astronomy theme. So it's great to play around with. I would not recommend starting there in Tinkercad, but it is a fantastic option. The next one that we're going to look at is circuits. Tinkercad has an amazing circuit simulator. Again, this is not something that I would have used with my elementary students, but if you were at a more advanced level, thinking about high school students on a specific grad pathway, the circuitry simulator is fantastic inside of Tinkercad. They have microbit options, Arduino options. It's really, really well done. So that would be something worth looking into if that was of interest to you. And then the third one is 3D design, which is where most people end up when they have the idea of teaching kids about 3D modeling and potentially 3D printing. So from here, I'm going to click on Start Tinkering. And here's again my home page of Tinkercad. I'm going to click on Designs, that's over here on the left-hand side, and Create 3D Design. That's where it gives me the option to choose if I want to do a circuit or go into code blocks. This is the platform of Tinkercad, and what you're seeing here is the work plane, which simulates the build plate inside of a 3D printer. So we're gonna work and build three-dimensionally off of the work plane. I'm gonna walk you through a tutorial that we use quite often for Tinkercad training because it's a relatively easy build, and if it is something that you wanted to explore the option of 3D printing, it's a rather quick print. Within Tinkercad, at this point, you can begin building just about whatever you want to. The first thing I always recommend students do is to change the name of their project. So up here in the upper right-hand corner, Tinkercad is automatically going to name and save the project, which is fantastic, but it's going to be a very strange name. And if I had a class of, say, 25 students and all of their projects had weird names, that would be rather confusing over time. So I generally have students type their name and then whatever the project is. Just makes it a little bit easier for identifying later on when it's stored within my class. The next feature that I want to point out is currently we're looking at the basic shapes in Tinkercad. Here it tells me it's basic shapes, and there's a drop-down arrow that will change all of the potential structures, images that I have within Tinkercad. So basic shapes is a fantastic place to start, but if you get into designing more and more, you might want to play around with design starters, things that you could build off of, like a dice. There are creatures and characters, there are structures and scenery, there are specific pieces of hardware. Featured collections includes collections from NASA, collections from the Smithsonian, so you'll find some really interesting pieces in there that are available to work with as well. What I love about this is that this is where Tinkercad goes beyond 3D printing, in my opinion. I see this being used by a language arts teacher, a social studies teacher, where you want the students to build something like an old school shoebox diorama. They could actually do it three-dimensionally here in Tinkercad. They could build out the walls of their box, then they could add in the people and the structures that represent the story they're reading, sharing a historical event by creating historical figures. I've seen book characters created using basic shapes. So the possibilities are really endless when you get into designing in Tinkercad. What we're going to focus on today is a very simple name tag. This would be something that could be hooked onto a backpack or a lanyard, but it's a really easy one to design and kind of get the basic understanding of how Tinkercad works. So we're going to live today within basic shapes, and we're going to start by dragging and dropping this red cube onto the work plane. When I do that, a few things pop up. I get this box here that gives me an indication that it's currently operating as a solid. I could change that to a hole, but we would not want to do that with the base of our name tag. You can actually make adjustments here as well, but I don't prefer to use this. I actually like working off of the work plane. So when my cube appears on the screen, I get these little white dots in the corners that allow me, by clicking on it, to drag and change the shape and size of my name tag. So by pulling a corner, I'm going to adjust the measurement, which currently is in millimeters. I can change that down here at the bottom. I actually prefer it in millimeters. I think it's great for students to start thinking about that type of measurement, especially when it comes to 3D printing, because you want most of your 3D prints to be smaller. So I'm going to leave it in millimeters, and I want it to be somewhere around 30 by 60. So I can actually click on the box itself and adjust the size, or I can drag it and adjust the size. So there's step one. The second step is I want to go to the center square. That's the one that adjusts the height of my name tag. And we're looking at this as just a base to the nameplate. And so I want it to be rather thin. I'm going to make this a 4, height of 4. So I just have this base to work off of. That is step one. Next, we're going to go back over here to basic shapes. I'm going to find this orange tube. It already has a hole in it, which makes it kind of nice for what we're going to use it for. I'm going to overlap it just slightly with the base that I just laid on the work plane. And then I want the next step to be, I'm going to adjust the size here. From the center, I'm going to adjust the height down to the same height of 4 that I had the other one on as well. And so if I look at it right now, I should notice that it's sitting above my work plane just a little bit. And so this is a great opportunity to share the perspective box up here in the upper left-hand corner. I'm going to change this view so that I can see it from the front. And then just by clicking on these little arrows that are hard to see, I can change the way that I see this. Well, what this is telling me is that my object, that tube that I placed, is not sitting all the way down on the work plane. It's kind of floating up above my platform. This black arrow is what allows me to move that. And so I want to move it to where it's now sitting at 0. That tells me that it's now in line, and you can see I can no longer see it. If I go back to my front view, I can tell that it's aligned now. Sometimes that happens when you drag it out. Sometimes it will be on the work plane. I don't have a good reason for why it does that or does not do that, but it is helpful to just check to make sure that it is in the correct location. And I'm going to move this just a little bit. I can center it here. This is where my lanyard would hook into my name tag, or if I had a ring, key ring that I wanted to use. I could also, drag this shape over to the end if I wanted it to be a name tag that looked more like this. I have lots of options here. For now, I'm going to leave it there. So we have our second component, our base and our ring. And the third thing that we're going to do is drag the text out onto the plate. So I found it here under basic shapes, dragged it out onto the screen, and I get this box that pops up again. And this is important because this is where I can adjust the text. So inside of this text box, as I'm typing, it's going to adjust the text on my screen. And then what I would need to do is, using those corners again, is just to resize it so that it fits onto the nameplate that I have. Now, if I'm clicked on the text, I again get this box currently on here telling me that it is a solid. So if I change the view again, what I'm seeing is my name stacked on top of the plate that I've built. Now, in a perfect scenario, if I was going to 3D print this, the less filament that I use, the better, the shorter the time it's going to take to print. And if I'm printing a classroom of 25 name tags, I would want them to be relatively short. So as long as I'm clicked on the text, I can again click on the center button that's going to adjust the height, and I can drop it all the way down to where it just barely comes off of the platform. That way it's going to use less filament and take less time. You can't really see that from this view. That's why that perspective box is really important. So again, while I'm clicked on the text and I have this box open where I adjusted the text before, I can also change my name to be a whole by just clicking. Currently it was a solid, I just clicked on the whole button. And what this does is it now shows my name going through the platform. So it actually would not print any filament in that space while 3D printing in an actual machine. The only problem with changing your name from a solid to a whole, in my case, is that this tiny little section of the A, this section of the B, and this section of the E would fall away because there would be nothing to hold it in place if I left it as a whole. That's really just personal preference. So for now, I'm going to change it back to a solid, but that's an easy pick there. The other thing that I'll point out, and kind of going back and forth between this, is if you're given the option to choose a color, students love to do this, go back and forth between colors. It's important for them to understand that if they're in the designing phase, they can change the color to whatever they want it to be. If they are printing it on a 3D printer, the actual color of the object at the end is going to be whatever colored filament is in that machine. So it doesn't really matter. A lot of times they spend so much time coloring here that it's a waste of time in the end. But if they were designing something from scratch that was going to be a digital 3D design, then they could use the colors in any way they want to. All right, so I currently have the base plate, my text, and the ring as 3 separate objects. The last step that I need to do before 3D printing, if I was going to choose that, is I need to
highlight and group all of these 3 items together. Right now they would almost 3D print as 3 separate things. So to do that, I'm going to pull my cursor off to the side, left click, and drag a box around it, almost as if I was highlighting. So left clicking, drag the box, and this pops up. And up here at the top, it's the 3rd image over. I want to group those items together. And I know that it's melded together because now the color changes to all one solid color, and my ring now appears as if it's part of the object itself. At this point, I am done designing a name tag. It's really simple, a great activity to play around and introduce Tinkercad to students. What I would do at this point is go here to export, and within the export button, I have either the option to save it for a 3D print or save it for laser cutting, which is kind of nice because you can use this platform for both. If I was going to 3D print it, I would save it as an STL. It would automatically save my document, and then I would have access to using a 3D printer and sharing that file to 3D print after slicing it. So, but the idea of Tinkercad at least allows you to see all of the different types of things that you can do. And because students are just so well versed in technology these days, just allowing them to play within Tinkercad after they've watched the tutorials, they would have an easy time learning and figuring this out. The last part of Tinkercad that I will point out are these buttons up here across the top. So currently I am working within the 3D design portion for building out a 3D design. That's showing you this symbol here. The next one is the newly created simulation lab. I'm going to click on it because it's really not going to work well for this particular object. I'll kind of share a different viewpoint of that here in a second. But the simulator allows students to add motion to what they're creating. This is fantastic if you're having students design a Pop-A-Shot game or a marble run or a maze of some kind that you want a ball to move through. They can use the simulator to actually simulate that movement to see if it would work correctly. It's a fantastic addition. The next one over here is more of a Minecraft Lego type feel. So what it's showing you right now is my name tag that I just built in block form. So students can actually build more of those Minecraft type designs in the blocks feature. And then this last one is the Legos. So it actually truly looks like Legos. This is what my name tag would look like if it was built out of Lego blocks. So those features are fantastic additions to just give you another way to use Tinkercad. It's fantastic. So as we wrap this up, I hope that you have found this interesting. If you're new to Tinkercad, I never used Tinkercad when I was in the classroom. I was a little bit intimidated by 3D printing, and in this new role where I am training teachers how to use 3D printers, Tinkercad has just been a fantastic resource, and I'm disappointed in a sense that I didn't use it in my classroom when I was with students, but it is a just fantastic way to add a 3D component or 3D design element into your everyday teaching. Thank you for joining me today in Tinkering with Tinkercad. My email address is amber@firstmakerspace.com with a 1ST. I will share that link with you. If you ever have any questions, I'm a valuable resource that's happy to help you at any time. Or you can visit our website at www.firstmakerspace.com. And again, that's with a 1ST. First Makerspace has free STEM curriculum. To access this curriculum, visit www.firstmakerspace.com. Click on Curriculum at the top of the page, create your login, and you will have access to all NGSS K-12 lesson plans.